Hi Year 8, welcome to your first video for remote learning. So we're going to be starting a new chapter today. We're starting equations. So if you are a title page kind of person, equations, and this is chapter 2 from your textbook. So heading for today is just simple equations, and we're going to go over some things that you learned in year 7. Just to remind ourselves before we move on to the year 8 level equations next week. So an equation is an algebraic expression, which you will remember is like a number sentence with numbers and variables and plus, minus, times, divide, all those things. So an equation is an algebraic expression with an equal sign. So if you see an equal sign, it's automatically an equation if there's something on the other side. In an equation, our variables or pronumerals now have a specific value that we're going to find. So what I mean by that is, previously we were looking at expressions like this, where x could be 1, 2, 3, 4, could be like negative 100, could be fractions. X could be anything. So x is a variable, or the other word for that is pronumeral. That is a label for any number that you want to substitute in there. In an equation, we have something that this expression is equal to. So there's only one thing that x can be equal to. So now x is an unknown. So it's still a variable or a pronumeral, but it's unknown because there is a specific value. We just have to work it out. So those of you that remember last year really well are looking at this saying, well, this is an equation that says 4 times some number plus 1 equals 9. And the only number that's going to make that true is 2, because 4 times 2 is 8 plus 1 equals 9. So that's what we're talking about when we're dealing with equations. We're going to be solving 1- and 2-step equations today, which is what you learned in year 7. And what we're going to do is we're going to be working backwards or doing the opposite to both sides of the equation. So these are things that we're going to be doing throughout this whole chapter. So we'll go through a few examples. Example number 1, and as we go through these, I want you to really take note of how I'm setting out my work. So example 1, x minus 5 equals 14. I've written out the question. Then here, x has this minus 5 next to it. I want to get rid of everything that's around x. I want it to be just x on its own on one side of the equation. So I need to get rid of this minus 5. So when I do the opposite, what I'm going to be doing is plus 5. But if I do that to one side of the equation, I also plus 5 on the other side. So I'm writing my working out. These green numbers is my working out. So I suggest that you have 2 colors of pens, or maybe your pen and then a colored pencil, so that you can write your working out in a separate color. It will make your setting out really neat and easy to read. So if I take x minus 5 and I plus 5 onto that, that means my minus 5 is gone and I'm just left with x. Still got my equal sign. You'll notice that I'm writing that directly underneath. And then 14 plus 5 is 19. So x must be equal to 19. That's the only thing that we can sub in here that will make this equation true. All right, example 2, same thing. I have m over 6. Now that means m divided by 6. I want m on its own, so I'm going to do the opposite of dividing by 6. I'm going to multiply both sides by 6. So when I multiply by 6, that fraction is cancelled out and I'm just left with m equals, again my equal sign directly underneath, and then 3 times 6 is 18. So the only thing that we could sub in here for m to make this equation true is 18. Okay, those are one-step equations because we only have to write one set of working out numbers in order to get our next line. This next example, example number 3, is a two-step equation. So when we have a few options of numbers to get rid of around x, we always start with the constant. So the number that's off on its own doesn't have any pronumerals attached to it. So the opposite of plussing 4 is to minus 4 from both sides. So now these cancel each other out, and all I'm left with is 7x on the left, equals sign directly underneath for my setting out. And on the right, negative 17, take away another 4 is negative 21. Be very careful with your negatives in this. And then here I have 7 times x, so the opposite of timesing by 7 is to divide by 7 on both sides. And I'm left with x equals negative 21 divided by 7 is negative 3. Okay, one more example. In this one, I've thrown in a few tricky things just to make sure that you've seen it all before you have a go at your questions today. So here, my x is on the right-hand side. That doesn't change anything. I'm still going to be getting rid of the numbers around x until x is on its own on that side. Here, I'm also going to end up with a fraction as my answer. I've done that deliberately so that you can see it's not just whole numbers when we're looking at equations. So, here I have 11 minus 8x. The constant, the number that's on its own with no letters attached, is a positive 11. So to get rid of that, I'm going to take away 11. So even though there's no plus or minus in front, I know that if it's positive, I get rid of it by taking it away. So 8 take away 11 on the left is negative 3, equal sign directly underneath the other one. My 11 is gone, but notice that I still have a minus with the 8x. So that minus is stuck with the 8x, and we're not going to get rid of it just yet. So on the right-hand side, negative 8x. Okay, from there, I'm going to get rid of the other number that's next to x, and this is negative 8. So I'm going to divide both sides by negative 8 rather than just 8. So that negative sticks with the number that it's in front of. Then, over on the left, I'm going to end up with a fraction. Negative 3 divided by negative 8 is just 3 over 8. So I'm writing it as a fraction. I try not to use decimals in equations, so always write your answers as fractions. Improper fractions are okay. And here I had a negative divided by a negative, which is why my fraction is positive. And then over on the right-hand side, that negative 8 is gone, so I'm just left with x. If you really want to, you can write an extra line of working that says x is equal to 3 over 8 with the x on the left, but this is okay, and you will never lose marks for having it this way around. It's just neater to have the x on the left if you choose to do that. So you're going to be working through a couple of questions today. You're looking at exercise 2b, questions 6, 7, 8, 9, 10. You must write down the equation before you start solving it. You must show those little numbers that I'm writing in a different color. And you must mark your work when you are done. Now, take note that in equations, setting out is very, very, very important. I want you to write neatly. I want you to make sure you're writing on the lines and that your equal signs are lined up exactly in one vertical row. All right, have fun.